Therefore, this product RC is called as time constant. How to define this time constant? So time constant of the series RC circuit is defined as the time during which capacitor charge increases to 63.2% of its final maximum charge. So it says that the charge becomes equal to 0.632 times of Q naught. If you calculate it in percentage, it will be 63.2% of its final maximum charge. That is 63.2% of Q naught. Therefore, the time constant of RC circuit is given by T is equal to R into C. It is very, very important relation. Problem may be asked on this relation. Okay, by giving the series RC circuit, usually the calculation of time constant will be asked. Usually. So next we will find out what will be the voltage. Charge charge is Q is equal to Q naught into 1 minus e to the power minus t by R. If you want to find out the voltage, instantaneous voltage across the capacitor. So what you have to do, divide the equation of charge by capacitance C. Divide this Q by C is voltage. Q naught by C is V naught, where V naught is the maximum voltage, that is equal to battery voltage. So Q naught by C is V naught, Q by C is V. Therefore, this V becomes equal to V naught into 1 minus e to the power minus t by RC, where V naught is the maximum voltage across the capacitor, that is equal to the battery potential. Okay, battery voltage charge. So now look at the expression for Q and expression for V. They are exactly similar, exactly same either. Q equal to Q naught into 1 minus e to the power minus t by RC. Voltage V equal to V naught into 1 minus e to the power minus t by RC. So this is the charge in the capacitor. This is the voltage across the capacitor. Okay, so both are exponentially decreasing with time. Exponentially decrease with time. If you plot the graph, how this graph looks like? So sorry, exponentially increases. Sorry, decrease increase. So if you look at the graph, this is the exponential increase graph. So both V and Q are having the same nature, and initially the voltage and charge increases fastly, then it becomes saturated and it will become constant, and that constant value equal to V naught or Q naught. Charge adre Q naught, voltage adre V naught. At T is equal to RC, and you will get the voltage or charge equal to 0.632 times of V naught actual. So this is the time at which voltage or charge becomes equal to 63.2% of the maximum voltage or maximum charge. This is called as time constant. So what is the significance of time constant? You will see. So before that, we will try to find out the current. You get charge find out voltage. So we'll try to find the current. So how to find the current? The instantaneous value of charging current through the capacitor can be obtained by differentiating the equation. So because we know that current equal to dq by dt. So dq by dt will be equal to d by dt of q naught into 1 minus e to the power minus t by RC. You have to differentiate this with respect to time, where q naught is constant, dq by dt is nothing but current. So q naught is constant, you take it out. So d by dt of q naught minus d by dt of q naught into e to the power minus t by RC. I will open the bracket. The bracket open madre, this will become q naught minus q naught into e to the power minus t by RC. ಎರಡು term ಬರ್ತದೆ, ಎರಡು term ಅನ್ನು differentiate ಮಾಡಬೇಕು. Q naught is constant, therefore derivative of q naught is 0. You will get I equal to ಇದರ differentiation ಮಾಡಿದ್ರೆ ನಿಮಗೆ q naught into e to the power minus t by RC. Then you have to differentiate this 1 by t by RC with a negative sign. So you'll get minus of dt, minus ಬರ್ತದೆ. Derivative of t by RC with the minus sign is minus 1 by RC. Okay. Then you simplify it, you will get q naught by RC into e to the power minus t by RC. What is this q naught by RC? Q naught by C is voltage, V naught. V naught by R is current I naught. Okay. So Q naught by RC is nothing but the maximum current I naught. So here I naught is given by Q naught by RC is the maximum current in the circuit. So this shows that the charging current falls as time increases. Time increase aitandre exponential of this minus T by RC decrease ಆಗ್ತದೆ. Therefore, current decreases with time. Okay. And at T is equal to RC, if you calculate, the value of current I becomes equal to 0.37 times of I naught. Note this point, current decreases, whereas the charge and voltage across the capacitor increases, whereas current through the capacitor decreases, and finally it will become zero. So time constant in terms of current can be defined. The time constant of the RC circuit is also defined as the time during which the charging current falls to 37% of its initial maximum value. Okay, 30%, 37% of the initial value is observed at T is equal to R into C. So this is the graph. If you plot the graph of this equation, I versus time, exponentially current decreases. And at T is equal to RC, the current becomes 0.37 times of that I naught maximum current. So one point you have to remember, in case of series RC circuit, during charging of the capacitor, charging agಬೇಕಾದ್ರೆ, charge and voltage have same nature of behavior. Same behavior is a similar equation is that, and both the charge and voltage increases and the current through the capacitor decreases. Note this particular point. During charging, both the charge and voltage increases. Charge ಆಗ್ತಾ ಇರ್ತದೆ. Charge ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Charge increase ಆಗಬೇಕು. Voltage ಕೂಡ increase ಆಗಬೇಕು. That is the meaning of charging. Whereas current decreases. That is very important point. So current through the capacitor decreases with time, and the expression for current is given by this particular relation, that is I equal to I naught into e to the power minus T by R, where I naught is the maximum current and current I decreases with time. Okay, so this is about the voltage, charge and current in series RC circuit during the charging phase. Okay, some important points you remember. The time constant RC decides the time of charging of capacitor. The value of resistance and value of capacitance connected in the circuit decides the time of charging. If RC is smaller, if RC is larger, capacitor charges very slowly. So it takes more time. RC is larger means what? Time constant is more. Time constant ಜಾಸ್ತಿ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? 63.2% charge ಆಗಲಿಕ್ಕೆ it needs more time, so that capacitor charges very slowly. It is observed that after 5 times RC, the capacitor fully charges, achieves maximum voltage equal to that of the battery. Full charge ಆಗಲಿಕ್ಕೆ ಎಷ್ಟು time ಬೇಕು? What is the time required for full charging? That is approximately 5 times RC. If RC is 100 seconds, minimum 500 seconds is needed to charge the capacitor fully. Just to remember for your knowledge. Then fully charged capacitor does not allow the current. Therefore, charging current becomes zero at that point. When capacitor charges fully, the charging current becomes zero. That is obvious. Current decreases and it becomes zero when capacitor is fully charged. When capacitor is fully charged, the maximum energy will be stored in it, which is equal to half C V naught square, where V naught is the battery potential, C is the capacitance. If value of resistor is small, the capacitor gets fully charged in a short time. If you want the capacitor to charge quickly, what you have to do? You connect a smaller resistance. Okay, then what you can do? You can charge the capacitor quickly. Okay, so then rate of decrease of charging current is greater. Current also decreases. Current decreases faster, whereas charging voltage, that is charging of capacitor, will be done quickly if resistance is smaller. Okay, that is how you can charge the capacitor in a quick time by connecting a small value of resistance. Okay, this is about the charging of the capacitor and its analysis. Okay, next we will move towards the second section, discharging of capacitor. I will share the notes in the chat box after this discussion. So let us consider the discharging of capacitor. If a charged capacitor is connected in series with a resistor, so what will happen? Okay, if a charged capacitor is connected in series with a resistor, okay, then what will happen to the voltage, current, charge, etc.? Basically, we'll concentrate on charge. Okay. Suppose a fully charged capacitor is connected in series with resistor along with a switch. The capacitor discharges to resistor if switch is closed. This is the circuit. Okay. A fully charged capacitor whose charge is Q naught, which is connected in series with a resistor. Then a switch is connected. When switch is closed, the circuit allows the current. And now capacitor is fully charged, which is having the charge Q naught, and it acts like a battery. It will send the current. Fully charged capacitor has stored electric energy, and definitely the charged capacitor has electric energy, and that energy gets dissipated in the resistor in the form of heat and radiation. When the capacitor discharges, the resistor will consume that energy. It will dissipate that energy in the form of heat and radiation. The discharging process takes place for a short time and shows the transient phenomena. The variation of current is going to take place. The opposition by the resistor for the flow of charges makes the discharging process a controlled one. That means the resistance opposes the current. That's why it will control the current which is passing through it. Because of that, the capacitor discharges slowly. If resistance is not connected, capacitor will discharge quickly. Within no time, it will get discharged. And that's why the value of resistance controls the current. Otherwise, this is the time constant. R into C is the time constant. We have seen that in the charging case. Same is true in the discharging case also. So let us find how this charge on the capacitor decreases. Discharge ಆಗಬೇಕಾದ್ರೆ ಯಾವ ತರ Q value decrease ಆಗ್ತದೆ ಅಂತ ನೋಡಿ next. So let us consider this circuit. Consider a circuit in which fully charged capacitor C is connected in series with resistor of resistance R. If a switch is closed, the capacitor discharges from its initial voltage, say V0. The capacitor was charged to V0 and initial charge is Q0. When switch is closed, capacitor start to send the charges through the circuit. Our current flow start ಆಗ್ತದೆ. Let I be the instantaneous discharging current. I be the instantaneous discharging current, and voltage across the capacitor plate reduces to 0 from V0. Voltage decrease ಆಗಲಿಕ್ಕೆ start ಆಗ್ತದೆ. Voltage start to decrease as time increases. Okay. Now let us apply the Kirchhoff's voltage law. Applying the Kirchhoff's voltage law, KVL to the loop, it gives voltage across the resistor plus voltage across the capacitor equal to 0. Okay, only two components are there. So algebraic sum of voltage and IR product equal to 0. So VR is nothing but IR. Voltage across the resistor is given by product of current into resistance, and VC in this case is minus Q by C. The negative sign indicates that charge is decreasing. So voltage is decreasing. VC is decreasing. So that is minus Q by C. Substitute here. So you'll get IR minus Q by C is equal to 0. We have got the equation. But we have to find the expression for charge. But there are two variables, Q and I. What you have to do? We have to substitute for this I as I equal to dQ by dt. Because I is dQ by dt. Then you will get the first order differential equation. We have this equation IR minus Q by C equal to 0. But we have I equal to minus dQ by dt. Why minus sign is taken? Because it is a discharging process. Current is decreasing. Discharging process ಅಲ್ಲಿ charge decrease ಆಗ್ತಾ ಇರ್ತದೆ. Change in charge is negative. dQ is negative. That's why minus dQ has to be taken. Substitute here. ಇದನ್ನು substitute ಮಾಡ್ರಿ. You will get minus R into dQ by dt. I ಇದ್ದಲ್ಲಿ dQ by dt substitute ಮಾಡ್ರಿ. Minus Q by C equal to 0. This is the first order differential equation. We have to solve it. That's all. And finally, we have to solve the equation to find the expression for Q. That is our aim. Now, separate the variables. Separation of variables you can do. So rearrangement you can do, you will get dq by q is equal to minus dt by rc. So take this dt to the other side. Initially take this minus q by c to the other side. You will get dq by dt equal to q by c. R ಅನ್ನು ಮತ್ತೊಂದು ಕಡೆ ತಗೊಂಡ್ರೆ you will get rc. Q ಅನ್ನು left hand side ತಗೊಂಡ್ರೆ you will get dq by q is equal to minus dt by rc. This can be done very easily. One step I have skipped, that's all. So believe me, dq by q will be equal to minus dt by rc. Separation of variable is done. The term containing q is on the left hand side. The terms containing some constant and t is on the other side. Now you integrate it. Integrate it, you will get integration of dq by q is equal to minus dt by rc. Integration of dt by rc. Integrate it. 1 by q. Integration of 1 by q is ln of q. Okay. You will get the solution as ln of q is equal to minus t by rc. Integration of dt is t. R and c are constants. Plus some integration constant c. Okay. Where c is the integration constant. To find the value of c, what you have to do? You put the initial condition. When t equal to 0, what was the charge? Remember, this is the discharging case. Initially, the capacitor was fully charged. That's why charge on the capacitor is q naught. Full charge ಆಗಿರೋ capacitor connect ಮಾಡಿದ್ರಿ. Then it discharges. That's why when t equal to 0, q will be equal to q naught. So put t equal to 0 here. This term becomes 0. Then q will be equal to q naught. Therefore, c becomes equal to ln of q naught. Okay, I have skipped the step. Q equal to ln of q naught ಬರ್ತದೆ. Then you put the value there. Okay, and finally, if you simplify that, you will get q is equal to q naught into e to the power minus t by rc. You have to convert that logarithmic equation into exponential equation, etc. That step I have skipped, but I have included that in the notes. Notes ಅಲ್ಲಿ include ಮಾಡಿದ್ದೇನೆ. Okay, so finally, ನಿಮಗೆ instantaneous charge during discharging will be equal to q equal to q naught into e to the power minus t by rc ಬರ್ತದೆ. Note the difference here. Charging case ಅಲ್ಲಿ ಏನು ಬಂದಿತ್ತು ನಿಮಗೆ q is equal to q naught into 1 minus e to the power minus t by rc ಬಂದಿತ್ತು. But here you get q is equal to q naught into e to the power minus t by rc. So it shows that charge decreases with time. Charging ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, charge increase ಆಗ್ತದೆ. Discharging ಅಲ್ಲಿ charge decrease ಆಗ್ತದೆ. That is nothing but discharging. ಅಂದ್ರೆ charge must decrease. That's why you will get this particular equation. And I will share the notes and you can observe that. Similarly, the instantaneous voltage is also going to decrease, and that is given by v equal to v naught into e to the power minus t by rc. Simply you divide this equation by c, you will get v. V is equal to v naught into e to the power minus t by rc. So not no need to give much more importance here. And current I will be equal to minus I naught into e to the power minus t by rc. Negative sign indicates that the discharging current is opposite to the charging current. That's why negative sign is considered here. The negative sign indicates that charging current and discharging current are opposite in direction. Okay, and these three equations are derived for discharging case. Okay, idu kuda important ide. And we'll try to complete this discharging case by drawing the graph for charging Q, etc. And also, when t equal to RC, so we have this equation, Q is equal to Q naught into e to the power minus t by RC. If you put t is equal to RC, then you can get Q is equal to 0.37 times Q naught. So e to the power minus t by RC, if you put t equal to RC, you will get e to the power minus 1. If you calculate the value of e to the power minus 1, you will get 0.37. So charge on the capacitor will become equal to 0.37 times Q naught if t equal to RC. So therefore, in this case also, the product RC is called time constant of the circuit. And during this time, the charge on the capacitor decreases to 0.37 times the maximum charge on it. Okay, So time constant is also defined as the time during which charge on the capacitor falls to 0.37 times the maximum charge on it. They are same. Charging case aladre, charge increases to 0.632 times of maximum charge. Discharging case aladre, during that time t equal to RC, the charge decreases to 0.37 times of maximum charge. Okay, that is how you can remember it. So how we can represent the voltage, charge and current variation? So in this figure, you can observe the variation of charge, it is going to decrease. Both voltage and charge are decreasing. This equation, exponentially they decrease. This is the discharging case. And during time t equal to RC, voltage and charge becomes equal to 0.37 times of the maximum voltage or maximum charge. Then how current is represented? Current is represented like this. Remember, current is decreasing, but it is in the negative quadrant. You observe, this is in the fourth quadrant. Because current is minus I naught into e to the power minus t by RC. Okay, that's why current decreases in opposite direction. This is a decrease of current. Minus I naught in the zero, so it goes near to zero. It decreases, and during time t equal to RC, the current decreases to 0.37 times I naught. So in a discharging case, all voltage, charge and current, they will decrease with time. But in charging case, voltage and charge increases, but current decreases. So this point you have to remember in order to understand the concept of discharging. Okay.